right? Laws of refraction. Okay, so we have laws of refraction. Okay, laws of refraction. Okay, so when we are discussing about laws of refraction, it is very similar to laws of reflection. Laws of reflection, we have two laws of reflection. Which are the two laws? Incident ray, reflected ray, and the normal lies in the same plane. Second law, incident angle is equal to reflection angle. Okay, so angle of incidence is equal to angle of reflection. So likewise, in the case of refraction also, we are having two laws. Okay, so what is refraction? We have two mediums, right? Okay, we have two medium 1 and medium 2. Okay, both are having difference in their optical densities. Okay, both are not the same medium. They have difference in the densities, optical densities. Okay, so this one is called the normal. Okay, so the ray coming to the separation of the two medium is called the incident ray. So this angle is called the angle I, incident angle. So this is the expected path. From the path, the light may either it will bend towards normal or it will bend away from the normal. Okay, for example, if it is bending away from the normal, this is called the angle of refraction. Okay, so based on this, we have two laws of refraction. Okay, so what is the first law? What is the first law? What is the first law of refraction? First law. Angle of incidence, angle of refraction, and the normal lies in the same plane. Right? Lies in the same plane. It is called the first law of refraction. Now we have a second law. Okay, so what is the second law? Second law is having special name. What is the name? What is the name of special law? Second law? It is called the Snell's law. Right? Okay, so second law is called the Snell's law. Okay, so what is Snell's law? What is Snell's law? In Snell's law, what is Snell's law? Sin I by very good. Okay, ratio means division, right? Ratio of sine of incident angle to ratio of sine of incident angle to refraction angle is always a constant, right? Okay, always a constant. Okay, so this constant is called the refractive index. Right, this constant is called the refractive index. Okay, so now we know that this refractive index, okay, we can find the refractive index in we can classify the refractive index into two types. Okay, so first one is called the absolute refractive index. Okay, absolute refractive index. Second one is called the relative refractive index. Okay, absolute refractive index and the relative refractive index. Okay, so what is absolute refractive index? What is the equation for absolute refractive index? N is equal to C by V. N is equal to C by V. Right. So what is C? Velocity of light through air or in vacuum. Okay, divided by velocity of light in the given medium. Okay, so actually what we are doing here to find the absolute refractive index of a medium, what we are doing here, we are comparing the velocity of that medium with the velocity of light in. Velocity of light in. So what we are doing here? We are comparing the. So actually what we are doing here? We are comparing the velocity of light in that medium with the velocity of light in air. Okay, or in vacuum. Okay, so for that we know the value of C. What is the value of 3? C 3 into 10 to the power 8 meter per second. Okay, so if it is, we are discussing about velocity, we are discussing about refractiveness of glass. Okay, velocity of light in air divided by velocity of light in glass. If we are discussing about water, velocity of light in air divided by velocity of light in water. Clear? Okay, so this is how we do it. Okay, so I'll show an example. So what is the example here? So for example, if I am saying, if I am discussing about glass, okay, we did this one now. Okay, so velocity of light in glass is 2 into 10 to the power 8 meter per second. Correct, right? Okay, so what is our equation? So if you want to write the refractive index of glass with respect to air, what is the equation? C by V. Okay, what is C? C is always a constant, right? So what is C? Velocity of light in air. Okay, so 3 into 10 to the power 8 meter per second divided by velocity of light in glass. How much?
2 into 10.
Very good. 2 into 10 to the power 8 meter per second. 10 to the power 8 cancel. Okay, so what is 3 by 2? 1.5. So 1.5 is the refractive index of glass with respect to air. So here we have relative refractive index. What is relative refractive index? So it's not like absolute refractive index. Okay, so in absolute we are comparing the velocity of one medium with the velocity of the air, velocity of light in air and velocity of light in vacuum. Okay, but here we are discussing velocity of light in one medium with the velocity of light in another medium. Okay, it doesn't need to be air. Okay, it can be any two mediums. Okay, so for example here you can write velocity of the second medium with respect to first medium. Okay, so the equation will be coming like v1 by v2. So actually what is v1 and v2? So here we can write v1 is the velocity of light in the first medium, v2 is the velocity of light in the second medium. Okay, so we'll do more problems or more numericals based on this one in the next class. Okay, got it? Any doubt in this class? Any doubt? Okay, if you have any doubt, you should clarify it. Okay, I told you, if you have any doubt, you should clarify in the class. If you are not clarifying the class, next time the doubt will be coming in the exam. Okay, at that time you will not have any chance to clarify. Got it? Okay, so I hope this one is clear. Okay, so if you have any doubt, you can ask in the next class. Next class we will go with the numericals based on this equation. Okay, happy? Happy? Okay. So okay, bye. You have any doubts seriously? No, no, no.